Hello my dear students, here is again your computer Wunsam, and today I will show you what variables are and what you can do with them. This will be a multi-part tutorial because variables are one of the most important parts in programming because they store data in a program while it is running. Therefore, variables are a form of storage location we present. Every variable has its own type, its own value, and their own different properties. And they work as a storage space for data. The most important properties for any variable are the following: the data type. The data type represents whether it is a number, a digit, a sentence, or just a small character. The variable name is something which can be chosen by yourself. For instance, you can select any variable name you want, like links, rechts, up, down, France, Spain, anything which is according to your fantasy. However, I would say that you should any variable name which has in fact to do with the program. The third one is the content or the value of the variable. So, for instance, if you have a number based on an integer, then you can say that the integer I with the variable name I has the value of 14 or has the value of 27 or the value of 1,456,214. The value of the variable depends mostly on the program you are using, and it also more or less depends on the type you have, because you can't use any words for an integer value. The last point are the so-called access rights and some other properties, like whether the variable is static or dynamic, whether the variable is public, private, or protected. But this is something for a more advanced course. We are only starting to create our own variables at the moment, and I want to make sure that you understand the concepts behind these variables as much as possible. Here are some of the examples of the most used data types in computer programming. Starting with the first one, this is a character, which is short for char. Char types are mostly used to store a single character or a single letter, which is surrounded by different quotes here, by single quotation marks, pardon me. These characters are mostly used to create some more sophisticated words or sophisticated sentences. Therefore is the second part, namely the string. This is a set of signs, so you can use different characters to create a string, to create a sentence, to create a word. However, most of the strings are just used as a single sequence of characters with its own variable. Like I said, string is used for sentences, for words, for longer combination of any characters we are going to use. The third one are the numbers, in this case the integer. Integer is for a whole number from -2 billion to +2 billion, and they are used for different properties which we can recreate to use for mathematical equations or something like counting and so on and so forth. There are multiple variants for integer numbers. Two of the most famous ones are short and long. Short is a shorter integer number with less numbers, and long is one with around 9 quadrillion or 9 quintillion numbers. So you only use long when int isn't large enough, but with 2 billion possible numbers that's hardly the case. Integer values are interesting for calculating simple calculations. However, if you really want to make calculations with more interesting values, with more discrete values, you always need some floating point types. Here in this case, the typical floating point number type is float. However, we don't use it too often because it's a little bit more complicated than using the so-called double variant. So we are using double to create our floating point numbers, or we also can use decimal. However, as I said before, these are all 3 different values, and double is the most easy to handle. And for the last example of a variable, we have the bool values. Bool values are named after George Boole, a mathematician who has created an algebra which only has 2 values, either of true or false. So let's see now, what can we do with these variables? And let us see what we can create by going to Programiz. Now we're back into Programiz, and as you can see, we again got back to the same example with console.writeLine, hello mono world. Now again, if I press 1, you can see it works. However, we aren't here to show that console.writeLine works. We want to show you how the variables actually are declared. We are again starting with the character variable, which is char. Then we can say a character name like output equals, and then we can choose what we want to use as a character. However, for the moment we need to create this single quotation marks to make sure that this is represented as a character or as a char. Then we can use anything we want, let's say an R. And now if we press 1, the only thing that happens is here again hello mono world. However, except if you forgot the semicolon in my case. As you can see now, it works again. However, we can use this to insert these values again by writing down output like this and then press 1. And as you can see, the output will be R. If we change it to G, then it will be G. If we change it to 7, if we change it to 7, then it will be 7, and so on and so forth. Q and then Q. We even can use, no, not again. We can even use at, and then at. And we can even use German umlauts, but then something interesting happens. You will see that there is a question mark. The reason for this is quite simple, because the umlauts can't be represented exactly in this sense. This thing here is only capable of representing 256 different characters, and the umlaut R isn't here. Okay, now we can use 3. If we use, however, more values, then you can see that there will be an error, too many characters in character literal. The problem of this is quite simple, because it can only use 1 character literal. I've shown you what a character can do. Let's see what a string can do. String name. I incline you to use some more sophisticated names, to be fair. However, in our example, we can just use them. Now, an interesting point is we can technically do this, and let's see what happens. Again, an error. You cannot convert char to string. The reason for this is quite simple, because this up there is a character, and this needs a string to work. A string is represented by single quotation marks, but we need double quotation marks. Then we need a specific value we want to use. Let's say here is the output. And then we can here write down there console.writeLine, and then we don't need to write down here is the output. It is enough if we write name, because this is the name of the string variable. As you can see, it works. It works. So we had the character and the strings, which aren't mathematically usable. Therefore, let's go starting with the other values, starting with integer. For integer, we only write down int, int, then let's say any number, and then we can say the number is 85, just as an example. Same procedure as before. We can write down any number and then press 1. And then this will be represented like this. It's the same case for using short or long. You can use any of them for your own advantage. Let's stay with short. Oh no, let's stay with int. However, you can even use any second number. Let's create it. Any second number. This equals 12. Let's say this 12. And we are going to an interesting property now, because integers are capable of calculating their numbers in themselves. So if we have 85 minus 24, we get 61. And here is any second number. Here we can say that it is 12. Then 12 times any number. Then let's see what happens then. Again, any number will be output because this is the variable name we are going to output. However, if we copy the any second number and paste it then here, and then run it, you can see that the calculation will be 732. This is because any number is represented as a variable, and 12 is the multiplication of this variable. This makes it a little bit more interesting to program because we can use any variable to calculate. The third one is usually float. However, as I said, float has a little bit of a problem because you need to write down a f at the end. This makes it a little bit more strange to calculate. That's why we don't use float. We are using double for any number with a decimal. So here we have double value equals 1.4. Then as you can see, if I press 1, nothing happens. However, we can use, again, the upper variables, like any second number, and multiply them with any number. Let's say any number. And then let's see what happens when we say value. Here you can see it is 85.4. Because it's 1.4 times any number, which is 61 times 1.4. And as you can see, it is capable of creating any float value you want. Now what you can also do is combine anything with different values here. Here, for instance, we have name, and combine it in console.writeLine by writing name plus value. For most of the part, it is good to keep one space here free, so you can see here is the output, exclamation mark 85.4. It is quite interesting to work like this because anywhere else it would be just too dense to work with. Now this is the last, this is the second to last thing I want to show you. The last thing is the bool value. Bool, let's say truth equals true. Now this is the last value because the truth values are mostly for either two values, true or false. They don't recognize any other values. So let's see what happens if we put them here too. Truth, and then see what happens there. As you can see, it works like usual. Here's the output, is in name, the string. 85.4 is the value, which is a double, and false is the truth here. To keep a little bit of a distance, you can again add some more strings. Here, for instance, I add the string to make a space between value and truth. You need to keep it in the quotation marks to make sure that the value is separated from the usual values. So if you have it like this, then it should be working now, and you can use any number here you want to create your own program. Just to be sure, don't forget the plus if you want to add something in console.writeLine. This is a specific feature of any string, because this is the only possibility to combine some numbers or something like this. I can't wait to see your beautiful programs, and I'm happy that you have been here. Yours sincerely, Computer Wonsam.